Hello, algebra students. Mr. Laurence here, and I'm just going to do problem number 4 from the section we did in class today. Yeah, this is to help you with your problems. Now look, if you just copy down my answers without doing it, you're cheating yourself. You think you're fooling me, but you're not. You're going to fail the test. Okay, don't be foolish. Learn from what I'm showing you. Try to model what I show you, but don't just copy down answers. I've got so many kids, just like, not so many, it's not a whole lot of you. Most of you are working very hard, and I am very proud of you. I hope I don't sound too negative. But I do have some kids who are just taking the answer key and writing down answers. Well, and then trying to get credit for that. I don't understand that. I'm giving you the answer key. I need to see the work that's involved. All right, enough preaching. Let's get down to this. So problem 4 says, Boyana, who thinks boys aren't very smart for thinking a girl would fall for them just because they have a shiny new rocket, doesn't worry about impressing people. Instead, she practices strengthening her arm for softball season. She has gotten so strong, she decides to see if she can throw the softball over our house without hitting it, of course. All right, she throws the ball from a height of 5 feet 6 inches with an initial velocity of 70 feet per second. And we're asked to find out how high does the softball go and when does the ball hit the ground. Well, I'm telling you, let's draw a little picture here. There's the ground. Let's draw Boyana. Boyana, no offense. Okay. Not a very good artist, but that's okay. There's the ball. And she's going to throw it, and it's going to go something like that, right? And if I'm asking you to find how high it goes, well, then I'm asking you for the vertex. Now remember, the vertex is going to have two parts. It's going to have a time coordinate, and it's going to have a height coordinate. We want the height coordinate, but we have to find the time coordinate first. Now, it says that her initial velocity was, where is it at? Where is that? 70 feet per second. Okay, 70 feet per second. And it also says that the ball is starting at 5 feet 6 inches off the ground. I don't want my units in feet and inches. I want them only in feet. Well, 6 inches is half a foot, so this will be 5.5 feet off the ground. Okay, so now I can write an equation, and my equation should be h equals negative 16 t squared plus a 70 t plus 5.5. And if I'm looking for the vertex, well, I can use that fact that t equals the negative of b over 2a. All right, so a, b, c. Easy as negative 16, 70, 5.5. All right, so let's plug in negative 70 over negative 32. And when we get that, it'll come out to be 2.1875. Okay? Now, if you want to convert that to a fraction, it's really easy. Just subtract the 2 off your whole number and hit your math frac button, and you're going to see that's the same as 2 3/16. Okay? That's the time it's going to take. It's going to take 2 3/16 of a second, so almost 2 1/4 seconds, because 2 1/4 would be this, wouldn't it? So it's almost that. But I won't use that for my calculations because that's a very different number than this one here, isn't it? I'm probably going to use this decimal. Oh dear, I always forget it does that, sorry. All right, I'm going to use this decimal for my calculations. See, I've only found the time coordinate. That's how long it's going to take to get there. Now I have to find the h coordinate by plugging in that decimal for t. So h is going to equal negative 16 t squared. Oops, excuse me, silly mistake there. Not really a mistake, but I need to fill in, I need to substitute in the time, which I only put a variable there. Okay, plus 70 times the time and then an add of 5.5. Now be careful. Some kids will lose the exponent here, and then some kids won't follow the order of operations. They'll multiply first and then square. Okay, this does not equal 100. No, it does not. Order of operations, exponents before multiplication. This equals 20 because 2 squared is 4 times 5 is 20. Order of operations. All right, so I'm actually going to go to my calculator for this part, and I've shown you how to do that. It should be pretty simple by now. Hopefully you're starting to do it. All right, and I'm going to get a height of about 82 6/100 feet. Now that's rounded. Okay, it was 0.0625, but that's pretty darn close. All right, so that's the answer to part A. The ball will go 82 6/100 feet high. Okay, now the second part says, when does the ball hit the ground? Well, if I'm asking when the ball hits the ground, I'm looking for this. And this, of course, is a t-intercept. Okay, it's, oops, I almost wrote x-intercept. And yeah, essentially they're the same thing, but since we're doing height versus time, or the height over time, then we're going to call it a time-intercept. Okay, so let's do the quadratic formula. So we're going to do, I'm going to go ahead and find my discriminant first because I have to do that anyway. I like to do my discriminant. I know there's going to be solutions. That's not why I'm doing it. I have to do it anyway. I might as well just go ahead and figure it out, and then I'll use that in my calculations. All right, let's see if that, excuse me. All right, so it looks like my discriminant is equal to 5,252, which is not a perfect square. I checked it on my calculator. Okay, it is not a perfect square. So I'm not going to use a decimal form of it. I'm going to take t equal to the negative of b plus or minus the square root of 5,252, and that's all going to be over negative 32. So there's two times here, right? Now, the first one would be this. And I'm going to let you verify what I'm about to say. I'm not actually going to do it. This one will yield a negative time. In other words, backwards in time. Looking at our picture, this one is going to get this part of the parabola here. It's going to get that x-intercept or that t-intercept. But that's actually backwards in time because it's to the left of where the ball is starting. So I don't care about that because that doesn't make sense in our problem. So for this one, for the other one, I'm going to get, oh my goodness, silly Mr. Lawrence, t equals t, a true statement, but not helpful. All right, negative 70 minus the square root of 5,252 divided by negative 32. And that will get me the correct answer. Now, let me get my graphing calculator up here. I'm going to model this one more time. I've shown a lot of you how to do this, and you just kind of think, well, you like your way better. Well, your way is not always getting the right answers. So I'm going to do the numerator in parentheses. So I'm going to go negative 70 minus the square root of 5252. Now, if you're on one of the calculators at school, you're going to have to put a parenthesis, two sets of parentheses. But on this model calculator, like some of you have, I think Michael Gregg and Dan Michael have these, maybe somebody else, you arrow out so you're not under the square root symbol anymore. And then I close this parenthesis. Okay, but if you were on one of mine in the classroom, then you're going to need two parentheses here. One to close the parenthesis that would be on the square root, and one to close this initial parenthesis. So this is the whole numerator, and I'm going to take that whole numerator and I'm going to divide it by negative 32. Okay, I have problems with that too. There we go. And that is going to end up being approximately 4 and 45 hundredths. Let's see, where are we Oh, okay. 4 and 45 hundredths. So t is going to be approximately equal to 4 and 45 hundredths seconds. So if I were really going to answer this really efficiently, because I'm trying to communicate with the reader, I'm going to say, let's see, where was the first one? It was, okay. So, oh, I lost it there. Boyana will throw the ball approximately 82 and 600 feet high, and it will hit the ground in about 4 and 5 seconds. See, I'm not just going to give the t equals as my answer. That's my mathematical answer, but I'm going to try to communicate with the reader as best I can. All right, that's it for the video. Like I said, I was just going to do the one problem for you. Hopefully you already had it done, or you can follow along and check your work. All right. I'm pretty sure the quiz is going to be Thursday. I'm going to move it back to Friday. But anyway, I will sign off. Mr. Laurence saying have a good night, everybody.